So we're going to move on to scientific method next. So one thing we're going to be doing a lot in this class is critical thinking. And sometimes I'm going to give the example of flat earth people. Have you guys heard about that? There's, I think, a documentary on Netflix. Yes. So those are the people who think the earth is flat, and maybe there's a disconnect in critical thinking there. So they can't really maybe understand the scientific method or how the information works, or how um, basically they can't understand science, or they cannot connect things together. So that's what's missing. So we're gonna focus on critical thinking in this class. So in science, it's a study of observable world. It means you observe something and you want to know why is that happening, and you come up with a hypothesis, and you do an experiment, and you have evidence for your basically answers. Basically, you give it evidence if your hypothesis is supported, why is something happening. So hypothesis, a lot of you guys might have heard about hypothesis, and you think it's an educated guess. Hypothesis is a testable explanation. That's the definition I want you to remember. It's a testable explanation of a phenomenon. And then the scientific method, it has different steps. We're gonna go over that. It's the way you test that hypothesis. The way, so it has a few different steps. We're gonna go over that. People who did the lab already, they already went over that. So science, it cannot answer questions like why I'm here, what's the purpose of life, if there's God. So it's just gonna answer the questions of the observable world. So we're gonna talk a little bit more about that next as well. So you're going to observe something in nature. So you observe maybe, you notice that I wear a sweater on cold days. That's your observation. And then you think of explanation, and an example of that would be, oh, she wears a sweater because it's cold. And then you make a prediction. If it's cold, she's going to wear a sweater. So I'm just giving a very general example. Or if it's, you check the temperature or the weather for next day, you say it's not cold, she's not gonna be wearing a sweater. So that's a prediction. Prediction definition for science is very similar to English definition. You're predicting what's gonna happen. If your explanation is valid, what's gonna happen. Then you come up with an experiment to test that. And then you maybe you collect some data, and then you analyze the results, and you do maybe a t-test or chi-square. We're not going to do any of that in this class, but there's a way you analyze the results. And based on your results, you're going to form a conclusion. In conclusion, you're going to decide if your hypothesis is supported or not supported. If it's not supported, maybe you're gonna go back and modify your hypothesis. If it's supported, you still want to go back and retest, and then you're going to report the results. So prediction, it's a statement that's based on your hypothesis, but it's you're predicting what's going to happen if your explanation is valid or if it's true. So a condition that should exist if your hypothesis is correct. And then another thing, the way you can analyze the data, or it's a model. So if you Google the word model, maybe, female fashion models or male fashion models gonna come up, or gym models gonna come up. Or, what we mean by model in this class is a math model. Basically, maybe you want to predict the weather, and you collect all the data, and you make a model in Excel or something. So you put all the data in. Once you do that, it should be able to tell the weather. So that's a model. So people use models in math. Experiment, you can design experiment to see if your prediction is true or your hypothesis is correct or not. So you can maybe come up with different groups depending on the type of experiment you want to do. So we're gonna go in that next. So variables, there are some variables that you have to keep in mind when you're designing an experiment. For example, your sample size, what's the number of sample size? What you're looking at maybe height. So that's going to be a standardized variable, or maybe you're only doing a study with the children. So all the people or all the subjects in your experiment should be children or a certain age. So, and then there's an independent variable, there's a dependent variable. We're going to talk about that in lab a little bit more. And then experimental group, we're testing on. And then what are you comparing them to? So you're gonna need a control group and experimental. Experimental, what you're testing, control, what you're comparing to. Data, you collect data on that, and it can be a survey, or it can be another type of data. So I'm going to give you an example of experiment on potato chips and stomach ache. So there was this company, they made these potato chips, and potato chips taste really good because they have a lot of fat and they have a lot of oil, right? So they said, we have this chemical that's called olestra, and if you eat these potato chips, you're not gonna gain any weight. So what happened was basically public relations nightmare. So someone went on news and said, these chips give me stomach aches, and people kind of freaked out. So what they did a study. So their hypothesis was olestra causes intestinal cramps. So that's their hypothesis. And then they went in and did their prediction. Prediction is people who eat these potato chips made with olestra will more likely to get intestinal cramps than the ones who eat regular potato chips or that don't have olestra. That's a chemical. So that's the prediction. And then they had to design an experiment. So they designed an experiment. They had a control group, and these people ate regular potato chips, and their experimental group ate olestra potato chips. These people didn't know which chips they were eating because they didn't want the results to be biased. So they didn't know which chips they were eating, and then they got their results. So 93 of 529 people got cramps, so 17.6%. And then here 15.8%. I want you to look at these results and tell me if olestra causes stomach ache. What's the conclusion here based on these results? People are saying no. So Catherine, why do you say no? Very similar in results. Beth said yes. Kunal said yes. The results were too close. So results are too close. There's not a significant difference. So if you were eating regular chips, you would still maybe get cramps because there is a percentage that's been shown and a certain number of people got stomach ache after even eating regular chips. So you were gonna get the stomach ache anyway if you were eating regular one or the other one. So there's not a significant difference. So your conclusion, it's going to be percentages are about equal. People who eat potato chips made with olestra are just as likely to get intestinal cramps as those who eat potato chips made without olestra. So these results do not support the hypothesis that olestra causes intestinal cramps. Does that make sense to you guys? This is a scientific method. These are the steps of scientific method. Yes. So going back, you know, there was an observation, there was an explanation for that observation, then a prediction, and did an experiment, and the results collected data, and based on that to form a conclusion. So once they did this experiment, this company, they published their results. And people who did not understand scientific method, or you know, there was a disconnect of critical thinking, didn't care about the numbers. They said, we're just not gonna eat these chips because it's gonna give us stomach ache, because they did not understand the scientific method. So I don't know if they continued with that or not. I didn't look into that, but that's what happened. That actually happened with that company. And then when I was talking about the experimental group and the control group, one group got the olestra chips, the other group got regular chips. They didn't know which ones they were getting because that creates a bias. So every time you are doing an experiment, you want to make sure you're not biased towards something. Let's say you really want to get this result. So you don't really want to manipulate your data because you really want the results to be a specific way. So you always want to make sure that there's no bias. For example of bias, I'm going to use this horse. His name was Clever Hans. And he was famous, I think it was 100 years ago, for counting. So his owner, he would say one, and then the horse would clap once. And he would say 1, 2, the horse would clap twice. And all the people would throw money because they thought this horse, could count. So what they did an experiment. And now not the owner, but another person said 1. The horse didn't do anything. And they said 1, 2. The horse didn't do anything. And the reason for that was when the owner said 1, he leaned in a little bit. And then the horse would clap once and he would lean back. And he would stay leaned until he counted to, if he said 4, he would stay leaned in until he clapped 4 times and he would lean back. Once he did that, he would give him some carrots. So he would get happy, and then he would give him carrots. So it was kind of a top behavior. So there was a bias there. So that's an example of a bias. So science is self-correcting process. What that means, if a hypothesis is supported, and then you go back and you collect more data, and that data is showing something else, that means your previous hypothesis is invalid. So it's a self-correcting process. Sometimes people say, oh, you're a scientist, how can you say you're wrong? But it's because science is based on data or scientific method. Every time you get new data, your results going to change, your conclusions going to change. So it's a self-correcting process because the scientists, they keep retesting, they keep rechecking each other's ideas. So what is hypothesis versus theory? What is the theory to you guys? What do you guys think is a theory? Sometimes people just say, oh, gravity is just a theory. Natural selection is just a theory. So what is a theory? Maybe tell me a definition that maybe you guys heard about or you guys think theory means.
I had a question about the potato chip study.
Yes, Stephen.
So would that kind of be like the placebo effect, like with medicine? Like a lot of those people thought they were going to get cramps from eating those chips, and then that's why the numbers were high?
Yeah,
Or
so they give a placebo.
Is it the same thing?
Yeah, so they give a placebo to a control group, but they don't know they're getting a placebo.
But does that make the numbers higher, though, of the people that think they're like, so the people that eat the regular chips, they think that there's more chance of them getting cramps, so they're going to develop those cramps like mentally, or is it just that's what happened?
No, they probably actually got cramps.
Oh, okay.
Yeah. The results can be replicated. So theory is the science is usually lip sync with data. Copy makes you short. Okay. A statement that can be proven multiple times. So Jacqueline said a statement that can be proven multiple times. So scientific theory. So you take a hypothesis, you test it once, it's supported. You test it twice, it's supported. You test it 100 times and it's supported. And then you test it 1,000 times, it's supported, becomes a theory. So hypothesis that's not been disproven after many years of testing, it becomes a theory. So gravity is just a theory, people say that, but we don't know if gravity works the same way in the whole universe. Maybe it works differently inside a black hole versus on Earth here. So once we have more information on that or more data on that, this theory might change. And the reason for that, I just said theory is a hypothesis that's not been disproven after maybe testing 1,000 times or 100 times. And then 101 time, you get a new data. Now your hypothesis is incorrect. So even if you test it 1,000 times and after testing 1,000 times, it's still true, it's a theory. But if you test it maybe another time and this time it's not true, it's not a theory anymore. So hypothesis can be disproven. Therefore, a theory can be disproven. So it can never be proven absolutely, can be disproven by a single observation or result that's inconsistent with it. So if 1,000 results are consistent, it's still a theory, but the next one, if it's not agreeing with the data is different or you have new numbers, then it's disproven. Does that make sense to you guys? Theory versus hypothesis?
Yes.
Yes, okay. And then there are laws, law of thermodynamics. Those are, or math laws, those are based on numbers. So those are different than hypothesis. Okay, so we're gonna talk about the limits of science. So science is an objective way, it's not subjective, of describing the natural world. Science does not address subjective questions. Like I said, why I'm here, what's the purpose of life, if there is God. or if she's pretty. So here's a picture. If she's pretty, science cannot answer that. Many years ago, females that were a little bit heavier were considered more pretty because they had maybe, it meant that they were wealthy, they had more food to eat, versus maybe today might have changed. So those are the question, or supernatural world. Science cannot answer that. Or and maybe if strawberry cake is better or chocolate cake is better. So that's a subjective question here. Science cannot answer that because some people, they might like strawberry cake better, whereas other people, they might like chocolate cake better. So you can do a poll of maybe 100 people and ask this question, and then maybe depending on what people like more, you can say people, higher number of people like this versus this, but you can't say, oh, this person likes chocolate cake or strawberry cake, because that's a subjective question.